Hey YouTube, this is Brendan with Cusack Prep, video explaining combinations and permutations. So what exactly is a combination and a permutation? Well, combinations and permutations deal with the way that you can order or group things. In particular, combinations are used when you're just concerned about grouping or combining something, but you're not too worried about the order. Whereas permutations would be where order matters. So places where order matters might be if you're running a race. It's different if you come in first place than if you come in second or coming in third. Those are all three different situations. And so if I was evaluating a situation like that, I would look towards permutations. On the other hand, combinations might be more appropriate if you're, say setting up groups in a class. So let's say a teacher has 15 students and she wants to collect 4 of them to be in a group to lead a classroom discussion. Now, if all 4 of the students hold the same position within that group, that would be a combination because the order doesn't really matter. However, if each of those students had a position, let's say one was the president, one was the vice president, and then maybe you had a secretary and a treasurer, that would be a permutation. So there are certain words that if you read in a problem can kind of hint you towards one or the other. So let's go ahead and type those out. So when we're dealing with combinations, any word that just means combined or grouped, you get rid of that underline, it doesn't look too clean. So let's say combined, makes sense, combination, right? The word grouped, or just anything dealing with like a committee or a class where everyone's on some kind of equal positioning. So I'm just going to put equal positions here. On the other hand, permutations would be kind of a different situation. So with permutations, we're concerned with things like order. So what kind of words would indicate a permutation? We write combinations up here. And then I'm going to go down here and give you some words that might indicate a permutation. So words that indicate permutations might be words like placed, arranged, ordered, just kind of anything like that, anything that indicates some kind of position. Now, what do these little exclamation points mean? So it's important that you know that that's called factorial. So a factorial is just a fancy way for saying you keep multiplying by successively smaller numbers until you get to 1. So for example, if I had something like 5 factorial, this just means 5 times 4 times 3 times 2 times 1. If I have something like 4 factorial, I would start with 4, and I just keep multiplying by smaller numbers until I get down to 1. So that would be 4 factorial. Now, what do n and r mean? So n represents the number of items that you are choosing from. So if you have a class that has 15 students, n would be 15. If you're trying to select a group that has 6 students in it, that's going to be the r value. So a lot of times this will be read as n choose r, meaning out of 20 students, you were choosing 4 for your group. And a lot of times people will treat this npr as n pick r. So out of the, 15 people that are running a race, you're trying to pick how many can finish first, second, or third. So without any further ado, let's go into some of these practice problems that I have down here at the bottom of the page. So in a race, trophies are awarded to runners finishing in the first, second, and third positions. That's an English error. If 8 runners run the race, how many different ways can trophies be given out? So we first have to ask ourselves, is this a combination or a permutation? And we answer that question by asking ourselves, does order matter? Well, that depends. If you think it doesn't matter coming in first or second, and then you might say it's a combination. However, generally speaking, on a standardized test or in your classroom, we are going to consider first, second, and third positions to be 3 unique possibilities, and there's a big difference between getting the gold medal and getting the silver medal and getting the bronze medal in, say, the Olympics. So this would be a permutation because order does matter. So because it's a permutation, we take a look at this formula, this NPR, and we see that it's equal to n factorial over n minus r factorial. So I'm first going to pick out what those two values are. Well, since there's 8 runners, I'm going to say that n is 8. And there are 3 positions that we're handing out trophies for. So I would say r is 3. Now, the formula is npr equals n factorial over n minus r factorial. So plugging in these numbers, we can see that n is 8, so I'm going to place 8 factorial on the top. And n minus r factorial is going to be 8 minus 3. And so we can see that that's 5 factorial. So if we have 8 factorial over 5 factorial, this is going to be 8 times 7 times 6 times 5 times dot 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 until you get down to 1. And on the bottom here, this is going to be 5 times 4 times dot 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 until you get to 1. Well, what's really nice about these problems is a lot of times these values will just cross off. So we can see the 5s cancel. I haven't written out the 4s, but the 4s would cancel, the 3s, the 2s, and the 1s. So we can see that all these values cancel. So all we're going to be left with is 8 times 7 times 6. And just a little bit of arithmetic will tell us that 7 times 6 is 42. And if we take 42 and we multiply it by 8, we would get, I believe, 336. Do the math really quick on the side here. And 6 carry the 1, 336. So that's how you would do a permutation problem. Let's take a look at the next one. Mr. Cusack wants to select 4 of his 20 SAT students to form a committee. How many different combinations can Mr. Cusack produce? So when deciding whether or not this is a combination or a permutation, we can see the word committee and the word combination, which does hint us to the fact that this is a combination. And I don't distinguish between the students in the group. I don't say one is the reading leader and one is the math leader and one is teaching the essay. I just simply say that there are 4 students that are going to be on this committee. So that leads me to combinations. So for combinations, we have NCR is equal to n factorial over r factorial times n minus r factorial. Now, in this case, n is 20, and our r value would be 4. So out of 20 students, we are choosing 4. So we can go ahead and plug that in. So we would have 20 factorial. R factorial would be 4 factorial. 20 minus 4 is going to be 16 factorial. Now, we're going to be smart about this. I don't want to write everything out because it's very time consuming. But what we know is 20 factorial, 20 times 19, 18, 17, 16, it goes all the way down to 1. And we know this 16 factorial down here also goes all the way down to 1. So what I'm going to do is I'm going to cancel during the process. So I'm going to write 20 times 19 times 18 times 17. And I'm not going to write the rest of this because I know it's going to cancel with this. In the denominator, we're going to have 4 times 3 times 2 times 1 because the 16 factorial has canceled out. So what could we do? We can kind of do some things to simplify this, right? If we're not using a calculator, this might make our life a little bit easier. So the 20 and the 4 can reduce to 5 over 1. 3 times 2 is 6, so if I take that 6 out and turn it into a 1, I can also turn this into a 3. And then we can just multiply the numbers straight across the top and straight across the bottom. And when we do that, we would find the total number of combinations. Now, I don't have a calculator with me, can't quite do that in my head, so I'm going to skip that step. But the main idea here is that you see the setup. That's what's really important. Now, in the ACT, you may see the final answer as just a number, whatever these are multiplied out by. But you also very well could just see this. They might leave it in that factorial form. And then finally, we can go ahead and take a look at this last question down here. How many ways can 6 books be arranged on a bookshelf? Combination or permutation? Well, we see the word arranged. Essentially, it's going to be different if you put, Huckleberry Finn on one side versus if you put your chemistry textbook on one side. I like books to be ordered, maybe like I'm kind of large to small. So it is different if you have the large books on the end and the small book in the middle. So that makes me think order is important. So therefore, this is going to be a permutation. But now, there's 6 books, but I don't have any other number. So what can I do? Well, we're going to assume that N and R are the same thing. generally it's safe to do this. So we're going to say that there are 6 books, and there are 6 spaces on the bookshelf for these 6 books. Now, the problem gets really complicated if you go beyond that. So for your high school course, they're really not going to ask you anything to that end. So what's going to happen here is we're going to have n factorial, which is 6 factorial, over n minus r factorial. So that's going to be 6 minus 6 factorial. Well, this is kind of weird. So we have 0 factorial. Well, what is 0 factorial? Well, it just so happens that 0 factorial is 1. And it seems kind of weird. 0 times something ends up giving you 1. For now, just accept it. For the purpose of the ACT, you don't really need to go into number theory in that respect. So just know that 0 factorial is 1. So this is just going to become, I'll write this down here, 6 times 5 times 4 times 3 times 2 times 1. And once again, we can just multiply this out. So it's 6, 24, 120, 720. So there's 720 ways that you can arrange 6 books on a bookshelf. That probably seems pretty high to you. You never looked at 6 books on the bookshelf and thought, oh, I can arrange that 720 ways. But now go ahead and look at your bookshelf. I'm sure you probably have one in your room, or maybe there's one around you at school. And ask yourself, how many ways can you arrange those books? And you're going to find it's a really, really large number. So anyways, I hope you found this video helpful as an introduction to combinations and permutations. Good luck on whatever test you have. Hope you enjoyed watching.